This expression is called a difference quotient because it's got a difference in it and a quotient. It shows up as the basic part of calculus. So if you're going on to calculus, a business calculus or an engineering calculus, you're going to see this formula, and a lot of what you do is based on this formula. Let's see from where it comes. I'm going to draw a little coordinate system here, and we're going to look at the slope of a line passing through a couple points. So here's x, and here's, instead of y, I'm going to use f. And suppose you've got a line here, and that line passes through, say, this point and this point. Now, when we've looked at slope before, here's what we did. We called this x1 and this y1. This point here, maybe we called it x sub 2, the second x, and this point here, y sub 2. And then we wanted to compare the horizontal change to the vertical change, right? So we wanted to look at this change and this change here. So this change right here, that was x2 minus x1, right? What is this distance? If this was 3 and this was 10, that distance would be 7, and you're getting it by 10 minus 3, or the second minus the first, right? The second minus the first. And the same for the vertical. What is this vertical? That vertical right there is going to be y2 minus y1, right? If this was, say, 5 and this was 8, that distance would be 3, and you're getting it by taking 8 minus 5, or in this case, the second minus the first. And then what we got was that the slope was equal to y2 minus y1 over x2 minus x1. So let's draw this again, but I'm going to relabel things. I'm going to do it a little bit differently. This will be x and f, and I'm going to draw that line. But now what I'm going to do is label this. I'm going to call this first point, I'm just going to call it x. It could be any x at all. See, back over here, what did you have? You had maybe a first point and a second point with a specified distance between them. Well, now what I'm going to do, I'm going to generalize this. That could be any x at all, any value at all. And now my second point on the line, I'm going to do this. I'm going to move however much distance I want. So I'm going to move maybe a distance h. So suppose I moved over this way h units. So where would we be? Well, if I moved over h units, that would take me up here, and then what would this value down here be? You know, if this was 3, and I moved over 7, right? I'm at 3, and if I move over 7, where am I? I'm at 10, right? And how'd you get to 10? Well, you did the 3 plus 7. But in this case, with the variables, it's just x plus h. And then what are these y values? Well, the y value is going to be the function value at x, right? So how do you get this value right here? You put x into the function and you compute. So instead of y, we're writing f of x. And now how do you get this y value here? All right, let's get that one. So how do you get that one? Well, to get that one, you put x plus h into the function and compute. So the y2, the second y, is going to be put in this x plus h and then compute with f. So it's going to be f of x plus h, right? These values here, these values on that axis are found by computing the function at these x values. So that x value gives me f of x. This x value I would put into f, and I get f of x plus h. So now what would you write for the slope here? So for the slope, we could write this. M is equal to, all right, I'm going to go back to the old formula and see what that does. Here's the old formula. So what is y2? So y2, that's the second y value, all right? That's this one. Here's the first y, here's the second y. So our second y value is f of x plus h. So we could write that, f of x plus h minus, right, minus the first y value. And the first y value that you come to is f of x. And this, of course, is all over what? The second x minus the first x. Now, the second x is this one here. x plus h minus the first x, and the first x is just x. But look at this, x minus x, that's gone. So what do you get? The slope is equal to, now here's the numerator, f of x plus h minus f of x all over h. All right, so there's that difference quotient, and what is it? Well, it turns out to just be the slope of a line. All right, so we have one formula for the slope, and you have another formula for the slope.